Hey, what's going on, everyone? Okay, let's get to this problem. The position of a particle at time t is given by s of t, and its velocity by v of t. Suppose that v of t is equal to blah, and that s of 0 is equal to 0. So we have some sort of starting position here. Find a general formula for position so that if we wanted to input some random time t, we would be able to use our formula to find out what is our position at that time t. That's what they're asking us to do here. So what we want to do is we want to add up all the changes to position and find out at time t how much has happened, how many changes have happened. Take, for example, the case when you're moving at a constant speed. So I want you to think about this in a different way. If your velocity is constant, it's the same thing as saying that we're changing position at a constant speed or a constant rate. Okay, think about that for a second. Make sure that makes sense. In other words, constant velocity means constant change in position. All right, fine. When velocity is not constant, things are different. So if we were the case where the velocity was constant here, so instead of this function, so note, by the way, that what's happening here is that at every time t, at every different time, we have a different velocity. Okay, that's making it kind of complex to find out what our position is going to be at the end of it all, because the velocity is always changing. If velocity is changing at a constant rate, let's say 3 meters per second, it's very easy to find out our final position. We just add up all that change that happened in the velocity, and then that's going to give us our final position. For example, if we travel at 3 meters per second, we just will add up how many seconds we traveled for and tag that onto our position that we started with, and that's going to give us our final position. So we do not have a constant velocity. So we have this situation. We know when we're changing position. Oh, we know we're changing position, but by how much? Obviously, the velocity is non-zero here at every time t. It's something. We want to know by how much are we changing our position. It would be really nice if there was a way to add up all the changes in position that we're experiencing. Okay. Oh shit, that's exactly what an integral will help us do. Integrals are really great at adding up infinitely many things, right? Velocity is change in position. So we want to add up all of the changes in position that happen from time 0 to time t. That's what we want to do. And that's what an integral does. It's a wonderful thing. So this is where our equation comes from. And you'll notice this from class. When you have a non-constant velocity and you want position, they say position at some time t is equal to your initial position plus the integral from 0 to t of vt dt. That's where that comes from. Okay, just this logic that we went through here. Okay, all right, so now's the computations. Now we just got to use that information, or use that formula, and we got to use fundamental theorem of calculus part 2. Unless you want to integrate that using Riemann sums, which I don't think you want to do. So let's get to it. So position at time t is equal to initial position plus this. That's what we had before. Position at time t is equal to 0. The only reason I know that is because they gave us that in the question right here. If they gave us that this is 7 or something like that, I'd have to put a 7 in there. 0 plus integral from 0 to t. Now I've just subbed out this velocity formula for what they gave me in the question. So there it is. And now what I'm doing is I'm using, this is where we use fundamental theorem of calculus part 2. The position is 0 plus, now the integral from 0 to t, remember fundamental theorem of calculus part 2 says if we had somehow an antiderivative of this junk in here, we could just evaluate the antiderivative at the end of our integral, subtract evaluating the antiderivative at the beginning of the integral, and that is the same thing as this whole integral here. So really, where f of t is any antiderivative of this thing here. Really, we just need to find an antiderivative and then we'll be okay. So for these ones here, you can just eyeball it. You're going to probably get, well, I know for sure you're going to get harder integration problems later. You're going to need one of 4 tools. It's not that bad, don't worry. But for now, we can kind of just eyeball it. So for example, we need something whose derivative gives us positive sine of t. Well, negative cosine will do the trick there because the derivative of cosine is negative sine, but if I already had a negative there, the negatives cancel out and we're all good. Throw a 7 in front of there because we need a 7 here. So negative 7 cos t is a good antiderivative for this one. Negative 3 sine t is a good antiderivative for this one because if you take its derivative, you get that one. So this antiderivative, it's one of an infinite number of antiderivatives. It works great. Another one would be plus 4. If I added 4 to the end of this, that's an antiderivative. And that would work perfectly in this question. You might ask, well, isn't that going to throw us off by 4? No, because when you subtract big F at 0, you're going to minus the 4 that you added on. So it's going to make absolutely no difference. You can use any antiderivative you want. Okay, let's continue. So this is antiderivative evaluated at t. So I just take this antiderivative and I plug in a t. That gives me this expression here. And now I have to take that antiderivative and plug in 0. So that's what I do. And now I'm just going to simplify some stuff. So cosine of 0, if you remember from your unit circle, that's a 0 angle. The x value is 1, so that turns into a 1. That's why I have negative 7 times 1. Sine of 0 from your unit circle, that is 0. The y value of that point is 0, so negative 3 times 0 is 0. This minus sign stays, all this shit stays, the 0 is gone, and at this point I'm just, so there's that one. The next one I simply rearrange. I put the positive 7 over there, minus that. So that should lead you to victory. I hope this helped. Let me know if you want me to do any other questions. Rock on, and we'll talk to you later.